Hey everyone. First of all, just tell me that if I'm audible or not. Yeah. Okay. As I can see, I'm audible. Yeah. Yeah. So, hello everyone. Welcome back to our channel. So, today's live is all about the NumPy arrays, okay, which is the backbone of the data science and machine learning. And in today's live, we'll learn how to manipulate arrays of any dimension, mostly 1D, 2D, and 3D, and then we'll explore all the NumPy's built-in statistical operations using some built-in functions present. Okay, so stay tuned up. Okay, so one more important thing, this is the second part. Okay, so the first part I've already created in the last live session. We have talked about the numpys. We have seen how numpy works, what are the submodules present in numpys, and we have explored some of the submodules also. Okay, so today we'll start from the very basics. Okay, so based on the previous live session, I have prepared some of the quiz questions based on yes or no. So if they will be correct, you have to reply with yes, and if they are incorrect, you will reply with no. Okay, so it will be a fun quiz session. So let's start with that. Let me just change with quiz. So guys, the first question for today is NumPy used for numerical and scientific computing in Python? Yes or no? So guys, your first question is now these questions which I have prepared is based on the previous live session, and they are very basic in nature. Okay, they are all about means these questions are based on informations about the NumPy module. Okay, no logical questions. So yeah, so the first question is NumPy used for numerical and scientific computing in Python? uh, okay, as I can see there are many replies also. So people are saying please start fast. Yes, we have started. um, okay, voice is clear. Okay, Madan is saying hi sir, hello. Sir, why there is no live daily? Because I just try to keep it up daily, but there are some other works because of that. Okay, sir, please explain about map filter reduce functions when you are free, please. Okay, sure. I'll take a quick 30-minute live session, okay, on map filter and reduce. Okay, I'll do it for you. Okay, so as I can see, couple of yes are in the chat. So those who are saying yes, yes is the correct answer. Okay, so I'll just write yes. Okay, let's move to the next question for today. Uh, Now, guys, the next question is question number two. That is, can NumPy handle multi-dimensional arrays? Yes or no? Again, repeat the question. Can NumPy handle multi-dimensional arrays? Okay, yes or no? Alejandro is saying good morning from Mexico City. Good morning to you, bro. Okay. As I can see, couple of people has replied as yes in the chat. Okay, so yes, for question number 2, yes, NumPy can handle multidimensional arrays, and we'll see today also. We'll see today that how we can create 2D, 3D arrays or 4D, 5D arrays. Okay, and then how we can do or perform slicing or accessing the elements in those arrays. So yeah, okay, guys. So yes, those who have said yes, it is correct. Let's move to the next question. That is question number 3. Uh, does NumPy stand for number Python? Yes or no? Okay, guys. So the next question is, does NumPy stand for number Python? Yes or no? Okay. So people are saying yes, yes. I can see a couple of yes in the chat and one no. See, number Python or numerical Python, both you can say, okay. It's not specifically number Python. You can call it as numerical Python also, but number Python is also correct, okay. So those who have said yes, it is correct. So the answer for question number 3 is yes, okay. Number Python or numerical Python is also there, okay. Yeah, I've told you. Yes, someone is saying that numerical Python, I got it. Yeah, numerical Python also and number Python, you can also say that. So both are correct. Okay, let's move to the next question. That is question number 4. Okay, let's see how many of you knows the correct answer of this question. Okay, which is question number 4, and it is very basic. So I'm sure those who have used NumPy, they will know this. The question is NumPy a built-in Python module? Yes or no? Okay, no, no. There is one yes in the chat, and okay, more no's. One yes is there. So those who have said no, yes, it is correct. It is not a built-in module. Okay, you have to install it, and for installing it, you have to write the command pip install numpy. Okay, so yeah. So no, those who have said no, it is correct. Okay, it is not a built-in Python module. You need to install it. Okay. Okay, then let's see how many of you have explored these things. Okay, so does NumPy, the next question, guys, the next question is question number 5, that is, does NumPy provide support for matrices and linear algebra? Yes or no? So does NumPy provide support for matrices and linear algebra? Yes or no? Okay, yes. Everyone is saying yes. Okay. Okay, so I can see couple of yeses. So we'll go ahead with yes. So those who have said yes, it is correct. Okay. Yes, it has a sub-module specially designed for linear algebra, and it provides support for matrices also in 2D array form. So yeah, and matrix multiplications for matrix multiplications, there are method presents. We have seen in the previous live session also that there was for product, there was for matrix multiplication, there was a dot function. So yes, the answer is yes. Okay, let's move to the next question for today. Uh, which will be the question number 6. Okay, one very basic question. Now the next question is question number 6, that is, can NumPy arrays hold elements of different data types together? Yes or no? So the question is, can NumPy arrays hold elements of different data types together? Yes or no? Now remember guys, I'm not talking about list. So don't get confused on a Python list and a NumPy array. Okay, they both are different thing. So don't consider it as list. Okay, so let's see how many of you are correct. Okay, okay, I can see no, mostly is no are there. Yeah. So okay, we'll go ahead with no. Very good. It seems that you guys have practiced it, or you guys know, you have explored this module NumPy. Okay, yeah. So no is the correct answer. Okay, guys. You cannot hold different types of data or different types of element in a single array. That is not possible. It should be of one type. Okay, it's not like list. List is heterogeneous in nature, but not array. Array is not heterogeneous in nature. Okay, so the next question is, okay, I feel that everyone should know this uh, question's answer. That is np.array used to create a NumPy array? Okay, and don't get confused, np is, we are importing the NumPy module as np. Okay, so np is that, so don't get confused. Just assume that we have imported the NumPy module as np. So then tell me, is np.array used can be used to create a NumPy array? Yes or no? And this is very basic. I feel that everyone should give the correct answer. Okay, okay. Yes, everyone is saying yes. Very good. And this was the very basic question also. So obviously, so yes is correct, guys. Yeah. Okay. Next question is question number 8. That is, uh, can NumPy arrays be indexed and sliced like Python lists? Yes or no? Okay, so the question number 8 is, guys, can NumPy arrays be indexed and sliced like Python list? Just like how you have seen list, in list we can perform indexing and slicing. Okay, so can we do it the same in NumPy? Is it possible? Yes or no? Okay, yes, yes, everyone is saying yes. Yes, yes is the correct answer. Yes, we can do that. We'll see today in today's class, in today's live session. We'll see that we'll create different dimension of arrays. We'll see the type, shape, and everything, and we'll try to access and slicing. We'll perform accessing and slicing on that. So yeah, okay. Let's move to the next question. So those who have said yes, it is correct. Okay. Uh, okay. Now I feel that those who have explored NumPy, okay, they only can answer this. Okay, I feel. Okay, so the next question is question number 9, and that is the data type of a NumPy array stored in D type attribute? Okay, yes or no? So is the data type of a NumPy array is stored in D type attribute? Yes or no? So D type is an attribute in NumPy. I'm not going to tell you more about D type, because if I'll tell you, I'll give you the answer. So first give me the correct answer and then I'll tell you about the D type. Okay. Yes, 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 I guess. Yes, yeah. Okay, everyone is saying yes. Yes. Yes is the correct answer. Okay. So yes, D type is an attribute which is used to tell the data type of your array. Okay. And which is by default present. It is a built-in attribute present in NumPy. Okay. So yeah. So yes, D type is an attribute, and yes, it is used to tell the data type of a NumPy array. Okay. Now the next question is in your screen, and it is question number 10. That is, does NumPy array take up more memory than Python list for the same data? Yes or no? Okay, no clue. Okay, no clue. Madan is saying no. Uh, don't know. I think no. Okay, okay. Uh, so I feel that most of you don't know about this. Okay, and there are few people who are saying no. So okay, so those who are saying no, it is correct. But uh, those who don't know, for them, okay, there are few points. Okay, just quickly explore it. First, I'll write the answer. Okay, and we'll just quickly explore. I'll just tell you the points. Okay, I'm not going to write it. I'll just tell you. See, let's do the comparison between a Python list and a NumPy array. Okay, so you guys will only tell me the answer. Okay, after this. So question is, does NumPy array take up more memory than Python list for the same data? Okay, let's say Python list can store elements of different type, means it is a heterogeneous in nature. So in list we can have integer, boolean, string, and complex values. All the values we can store it in a single list. But in array, can we do that? No, we cannot do that. All the elements must be of the same type. That is the data type of. Then on the storage basis, element is a separate Python object. Okay, in a list, each element is a separate Python object in a list. It is treated as a separate object. But in NumPy array, the elements are stored in a continuous block of memory. Okay, so because of, and in Python list, the elements are stored at different memory location. But in NumPy array, all elements are stored in a continuous memory. Okay, Then if we'll talk about the memory efficiency, so it is higher in Python list because it is overhead, uh, because of objects, because of object reference it is overdue. So higher means high overdue is present in Python list in comparison to NumPy array, because NumPy array is comparison to Python list much more compact and only stores the actual data, okay, not the objects reference. So that is the thing that makes the NumPy array uh, take less memory in comparison to Python list on the same data. Okay, and you can check this also. uh, do you guys want me to show you through codes? Okay, as I can see, people are saying so code. Okay, so I'll just quickly just let me just give you a quick review on this. Okay, so what I'll do, I'll just import system. Okay, and then I'll import NumPy as np. Okay, and I'll do what, I'll create a Python list also. So first I'll create a Python list and I'll store the same data in this. So I have the Python list with me. In this I'll store 1 2 3 4 5. Okay, and then we'll print the size of this. So Python list size, and what we'll do, we'll just use the system module to get the size of this. Okay, so get size of is the method we have already talked about this method. Okay, so I feel everyone knows about this method, which is present in the system module, get size of. Okay, and then we'll create a NumPy array. So let's create a np-arr in which we'll use the array function. Okay, and we'll just pass a list, or you can directly pass py list also, that also you can do. And let me just copy it and paste it over here. And so np-arr dot, and the attribute for getting the size in bytes is n bytes. Okay, and let's execute this. So guys, as you can see, the total difference here. Okay, which is clear. The list is taking for the same type 1 2 3 4 5, the list is taking 104 bytes, and Python NumPy array size is 20. Okay, so as you can directly calculate, it is taking, I guess, 4 bytes for each integer type. Okay, so yeah, that is there. So yeah, so the answer is no, that NumPy array takes less memory than Python list, not more memory. So yeah. Okay, let's move to the next question. Okay, so which question? 11. So question number 11, which is this. Is np.zeros used to create an array filled with ones? Yes or no? Okay, so Madan is saying, Madan Varalakshmi, yes, she's saying that, sir, will you teach us full Python course? Yeah, sure. I'm teaching you the full Python course. I have taught you the basics, loops and all. Then I have come up with the data structures. Okay, then I've come up with the oops concept, and now I'm came up with the data science course. Okay, now in the data science there are many things, so that's why I just initially had one session, okay, in which I have told you about how to perform data analysis, in which I have shown you a few steps, and I have taken a Titanic data set. Okay, now from that we just build up an idea, and now in the previous live session we started with very basics. I just give you an overview on NumPy, and in today's live session we are just uh, seeing the very basics things of the NumPy array, the NumPy module, the arrays and the statistical methods, and then we'll move forward and we'll explore all the sub modules of the NumPy module, and then we'll go ahead in that way, and then we'll explore the pandas, and then we'll go ahead and we'll see more of this. Okay, so for 11 people are saying no. Okay, and no actually filled with zeros. Yes, correct. So don't know. Yes, sir. So yeah, so those who have said no, it is correct. Okay, that obviously there is a common thing also, that if you will use zeros, so you cannot get filled with ones. So zeros function is used to create an array filled with zeros, not with ones. There is a another method for ones. So no, those who have said no, it is correct. Okay, okay, so let's do what, let's have the last question for this quiz session. Okay, and then we'll end up with end our class, not class, and we'll end this session. Okay, so guys, your next question is question number 12, that is, does NumPy have a function np.I to create an identity matrix? Okay, Varalakshmi saying so from that advanced Python start, sir. Okay, and is there advanced Python? Yes, there is advanced Python. Okay, actually it is what you say, it is the basics Pythons only with advanced features in that. Okay, so just like we have on the oops, we have heard about the classes and object, we have seen polymorphism and all, inheritance and all, but we have not created a meta class yet. So meta class, when we create a meta class, so that is an advanced topic in Python. So yeah, no, there is no such specific thing called as advanced Python. Okay, that is a normal Python only the features which we used, okay, that is little bit advanced to understand. Okay, those who have understood it is easy for them. Okay, but it is the extra features which has been added in Python, just like the meta classes example I gave you. So that those are the things. Okay, so yeah, so for question number 12, yes, no. Okay, so people are saying yes and no. So those who have said yes, it is correct. Okay, so for creating identity matrix, there is the function called as np.I, which we have to use. Okay, we'll see today. So we'll do what, we'll just keep this much only for this quiz session, and now we'll start with NumPy arrays. Okay, so I've divided this live session in two parts, or let's call it as a section. So first section will be based on, so section 1 is based on array operations. We'll see some of the basics array operations. Okay, so let's now start the practical thing. Okay, the practical class. So first of all, we need to import NumPy. Now I have already imported NumPy to give you an example, but again I'm importing it. Okay, so import NumPy as np, and I'll show you that how you can create a 1D array, how we can create a, what you say, a 2D array and then a 3D array. Okay, we'll see everything. So first of all, let's start with not 1D array. Let's start with a 0 dimension array. Okay, let's first start with a 0 dimension array, and let's see how a 0 dimension array is created. So I'll just name it as 0D, or let's say 0D. 0 dimension array. Now what is a 0 dimension array? I'll tell you. So I have A, and I'll use the array function to create an array, and a 0 dimension is that it has no row, no column, nothing. As we talk about the 1 dimension array, so in 1 dimension array we have a row, we go means we have multiple elements in it, if I'll tell you in simple words. But in 0 dimension there is only one item, only one element. Okay, so yeah, this is how you can create it. Then let's create a 1 dimension array. So b equals to, I'll do what? So b is an array, and now in this I'll pass a list to create an array. So np.array, in which I have passed the list 1 2 3 4 5, and the array function will convert that list into an array. Okay, so this is a 1 dimension array, and this is how a 1 dimension array look likes. Then we'll talk about a 2 dimension array. So again, a 2 dimension array will have both row and column. Okay, a tabular structure will be there. So row and column will be not a tabular structure, row and columns will be there, a matrix. So np.array. Okay, and in this, first of all, you'll take one square braces, then you'll take another. So whenever we talk about 2 dimension array, so just think of like in this nested list. Okay, how you create a nested list? First there is a parent list, and inside that parent list there are 2 or 3 or 4 child lists. So just like that, so we have a parent list, and then we have 2 child lists, 1 2 3 4 5 6, and this is a 2D array, and we have put it inside the array. So when we'll execute it and when we'll print C, so it will give us an array. Okay, so using list we are creating an array. Remember this thing. There are direct methods also using which we can create it, just like we have seen in the quiz session, ones, zeros, I, but for now we are not using that, we are just using this way. So this is 3-dimensional array. Okay, let's see how we can create a 3-dimensional array. So np.array, and for 3-dimensional array, okay, we have to follow three layer structure. So as you can consider it like grandparent, parent, and then the childs. Okay, so there is one grandparent, and this grandparent will have 2 parents, and in this 2 parents there will be in one parent there will be 2 subchilds, means 2 childs. So let's say 1 2, then comma, then 3 4. Okay, so this is completed for the first parent. Now in the second parent again we'll have 2 childs, 5 6, then we'll have 7 8. Okay, so this is a 3D array. This is how a 3D array looks like. So first of all there is a child. Okay, this, then there is a parent, and then there is a grandparent, or you can consider it in this way: parent, child, and subchilds. This is also one of the ways. Now we have created all the ways. Let me just execute the cell. As you can see, there is no error. The cell has been executed successfully. Now let's just print the dimension of these A, B, and C, D, these 4 arrays. Okay, and let's just re-verify it. So we'll print A dot, and for obviously there is a attribute present to check the dimension of an array, that is ndim. We have explored this in previous live session also, and today also. I'll just let you know. Okay, so for you have to check, if you have to check the dimension of an array, so ndim is an attribute of a NumPy. Okay, so NumPy array, actually nd array, it is an attribute of nd array, so it will be always applied on an array. And then for d, ndim, and let's check the output. What is the output? So 0 1 2 and 3. Okay, So as I have said, first one is the 0 dimension, then 1D, then 2D, and then at the end D is a 3D dimensional array. Okay, so this is how you can create multi-dimensional array. Okay, from 0D to 3D. Now if you want to create a more higher dimensional array, okay, just let's say a 4-dimensional array or a 5-dimensional array, so then there is an attribute called as ndmin. Okay, ndmin, so that you can use. And where you have to use that, let's explore that. So let's do what, uh, let's just create a simple array. Okay, simple array using a list. So np dot array, and let's just provide a list in it, a simple 1D array. Okay, 1 2 3 4 5. Now I want to convert this 1D array into a 5-dimensional array. Okay, so what I need to do, there is a parameter which is called as ndmin. Okay, this defines the dimension. Okay, so whenever I will apply this, so this is going to create an array with 5 dimensions. Okay, and yeah, that's it. And let's just do what, after creating this, let's just print arr, and let's just print the dimension of the arr. Okay, so using ndim, that's cool. Yeah, so as you can see, how it will look like, it will look like this: 1 2 3 4 5. Okay, and when we are checking the dimension, it is the dimension 5. Okay, dimension is 5 here. Now let's just do what, let's just try to convert this 3D array into an 5-dimensional array. Is it possible to do that? Let's see. So already we have created the 3D array as D, 3-dimensional array as D. The name of the array object is D. So yeah, we'll try to convert this. Okay, so yes, it's possible. So from this, what we came to know, that if we have an array, existing array, okay, and that array can be a 1D array, 0D array, 2D array, or 3D array. If any type of array you have, and you want to convert that array to a higher dimensional array, in most of the cases you don't need that. Okay, but if you want, if there is a situation, so then this is the provision to do that. You have to use this parameter ndmin, and you have to put the value. Okay, suppose if you want to 5-dimensional array, so 5. If you want a 10-dimensional array, so 10. Okay, and this is how it will look like, and this is the this attribute is telling that it is a 10-dimensional array. So actually there is a no need. If there will be need, now you know how to use it. Okay, so I just let you know that how you can do that. Okay, yeah, so we are talking about this ndim, that how we can check the dimensions. Okay, now let's explore more of these things. Okay, so what I will do, uh, now we'll use some of the basic array properties. Okay, basic array properties. So let's say we have, first of all, we have ndim with us, that we have already seen. So let's say if you are checking on C, so C dot ndim. So this is going to tell you the number of dimensions. Okay, number of dimension this array has. Then if you want to check, now guys, again I'm telling you, if you have any confusion in any of the codes, just let me know in the chat. Okay, so I frequently do check the chat, and I'll give you the solution for that. Okay, so any problem, just let me know. It's not like that I'm telling anything and you guys will listen anything. No, if you guys find that I am wrong at any place, or if you guys have not understood, so just let me know. Okay, we'll together try to fix that error, and I'll try to make you understand more nicely by taking more examples. Okay, so yeah, now if you want to check the shape in the sense of rows and columns. Okay, so there is an attribute called as shape. Okay, the name of the attribute is also shape only. So it will give you the output in this manner. First it will give you rows, okay, in a tuple format, and columns. Okay, And if you want to check the size, okay, that how many total elements are there, the size of your array, so then there is an attribute called as size. So attribute name is also size, so it will be easy for you guys to remember, okay, and for me also it is easy to remember. So yeah, c dot size. And then one last thing in this is, um, if you have to check the data type of your array, so then there is d type. So we have a quiz in our quiz session, we have a question also, yes or no question on d type, okay. So yeah, so this will tell you the data type of the array. Let's just execute everything and let's just see. So uh, for our C was a 2D array, okay, and as you can see the elements were 1 2 3 4 5 6, and this is how it looks like, okay. Now let's just go and check. So ndim for C is 2 because it was a two-dimensional array. The shape was 2 rows and 3 columns. Let's go and check. So yes, there was 2 rows, okay, because there was 2 childs, and in each row you can see there are 3 columns, and in the second list also there is, means in the second child list also there is a 3 column. So 2 comma 3, 2 defines rows and 3 defines the columns, okay, remember this thing, okay. Then the size. So size is total how many elements are there, okay. I've written also total elements. So total how many elements are there? So 6, as 1 2 3 4 5 6. And one more thing to find the total size is that if you'll find the shape, okay, so if the shape is 2 comma 3, so you will multiply 3 with 2 or 2 with 3 and you will get the total size of the elements, or total how many elements are present, okay. So yeah, that is also there. And then the data type of the elements is integer 32 bit, okay, 32. So because there were 1 2 3 4, okay, so integer 32 bit. So yeah, that is there. This is how you will check or re-verify your array. So these were the basic array properties or attributes, you can say, which you can check to re-verify your array or to check your array, okay, in simple way, okay. Yeah, now the next things the next thing which we'll see is, okay, in the chat everything fine, thanks, okay, very good. Okay, is go, what is go, bro? I didn't get you, can you please explain? Okay, Alejandro is saying, can we see the memory size array C, please? Yes, n bytes you can use, print c dot n bytes, so 24. So 6 into 4, okay, I guess 6 into 4 24, yeah, obviously. So 4 bytes is given to one integer element. This is the, because it is integer 32, okay, because of that I guess that 4 bytes has been given to each element of the array, okay. So I hope it is clear. And okay, n bytes is for the total memory taken by the array, okay, got it. Okay, we'll move forward, and I hope you got your answer, bro, okay. And now the next thing which we'll see is that array creation methods. We'll see all the methods using which we can create array, okay. So let's just do what, or let me just a b c d. So we'll start with e now. So e np dot zeros. Now we have seen some of few of them, okay, or many of them we have seen it in the previous live session when I was giving you an overview of NumPy, okay. So if you guys know this methods or functions, that's very nice, that's very good. If don't know, so this is the time I'm again telling you, okay. So yeah, that is there. So I have taken e, okay, my array name, and I'm using this zeros, okay. So zeros is a function which is used to create an array. And how you will create an array? So first of all, know this thing, that whenever you use the zero function to create an array, so all the elements inside your array will be filled with 0, Okay, the first thing. And the second thing, that whenever you use this zero function, so you have to mention that how many rows and how many columns you want. So suppose if I want 2 rows and 3 columns, so I'll give that, and then I'll print E. So this is how 2 rows and 3 columns array I have get, and you can see all the elements are filled with 0. Okay, so I hope you guys got this. So this was for np dot zeros function. Then the next function which we'll see is np dot ones. Now with the name only, I hope everyone would have understood, okay, that once every element will be filled with ones. Okay, and again it also works the same, just like how the zeros have worked. You have to mention the rows and columns inside round braces, okay, in a tuple format. So let's say 2 and 3, and let's print f. So you will get 2 row and 3 column, uh, 2 row and 3 column matrix or an array, as you can see, filled with 1. The next method is which we have explored, a range. Okay, guys, the next method is a range. Now again, I'm telling you, for a range, just like how the Python range function, if you guys remember the range function, okay, how the range function works: starting, ending. Starting is exclusive, inclusive, ending is exclusive in nature, then the step. Same ways goes with this a range. Okay, so ef g np dot arrange. In this arrange, what we are going to do: 0, 10. Okay, so what is this? It means we are starting, the elements will be started from 0, it will go till 9. 10 is exclusive in nature, so it will go till 9. So total 10 elements will be there because it's starting with 0, but 10 will be excluded. And if you want to give the step, so you can give the step 2. So it will start from 0, it will not include 1, it will directly go to 2, then it will not include 3, it will 4, then 5, it will not include 6, then 7, it will not include 8, and then because 9 it will not include, and 10 is excluded, so it will be till 8 only. So let's just see, give a look at the array G. So as you can see, it is a one-dimensional array. So a range always creates a one-dimensional array. And as you can see, when I've given the step 2, so 2, 4, 6, 8. So total 5 elements are there. Okay, starting from 0, going till 8. It is similar to the range. Range function is used to create sequence of numbers, and here the a range is used to create sequence of what? Sequence of array elements from the defined or determined starting part and the ending part. Ending part is exclusive in nature, just like the range function of Python. Okay, and let's just go ahead with uh, the next is np linspace. Now this method is used, guys, for creating heavenly spaces between two defined values. Okay, so let's say gh, so array name will be h, np dot lin space, and you will give the starting part, you will give the ending part, and this ending part is included in nature. And then the next thing which you will give is the next parameter which you will give inside linspace is, first you give the starting part, then you will give the ending part. Ending part is inclusive in nature and is starting also. And the last third parameter which you give is that uh, uh, how many spaces you want. Spaces, it says how many parts you want to do, how many heavenly parts, evenly parts you want to do between these 2 points, 0 and 1. So between 0 and 1, how many heavenly parts you want to do evenly. So I want 5 parts. Okay, so yeah, so as you can see, 0, then 0.25, then 0.5, then 0.75, and then 1. Okay, so 5 parts has been done, and all, if you'll do the difference between the second element and the first element, so it will be 0.25. If you'll do the difference between on the third part and the second part, the difference will be same. If we'll do the difference between the third part and the fourth part and the third part, it will be same. And if you want to do the difference between the last element and the second last element, so it will be same. 0.25 is the difference. Okay, so yeah, that is there. And then one more thing is there, that you can increase it. Suppose if you want 8, you want to divide this from 0 to 1, you want 8 heavenly parts of these 2 points, between these 2 points, so you can do that. Okay, if you want 10, so you can do that. If you want 20, so yes, you can do that. Okay, if this is 100, if you want to do 20, so this will be the output. Okay, if you do 10, so this will be the output. Okay, so this is how you can do that. If you make it 1, then this will be the thing. So yeah, it depends on you how you want to use it. This is the structure, this is the syntax which you have to follow, and this is the output it generates. Okay, and then when we'll come up with the different types of problems, and when we'll find the solution of those problems using NumPy in our further live sessions, so then you will understand it more better, in a more better way. Okay, then there is one method called as NPI. Now this is used for creating an identity matrix. Okay, what is an identity matrix? So only the diagonals will be filled. Okay, and the rest of the other elements will be filled with 0, I guess. Yeah, so that is an identity matrix. So yes, you can create an identity matrix using the method called as np.I. So gh, now the next array name is I, so I.np dot I, and let's say I want 3. Okay, and let's just print I. Let's just see the output. So you will see that you have got 3 rows and 3 columns. Okay, and obviously I means that only, that's why it is taking only one parameter. So yeah, and the diagonal, as you can see, they are filled with 1, and the rest of the other elements are 0. If you create a identity matrix of 4, okay, 4 rows and 4 columns, so the diagonals will be filled with 1, and the rest of them will be, the rest elements will be filled with 0. So this is an identity matrix, and this is how identity matrix is present. So again, because the name differs, identity matrix, and for that a name is used is as I, so yeah, people will get confused. So because of that, I'll write it over here that np.I is used for create an identity matrix. Now guys, I'm just giving you info, I'm just sharing you the info that these are the things which are present in NumPy. Okay, the main problem and solution thing I'm not doing yet, because we first need to do the basics thing. Okay, then step by step we'll go and we'll solve problems also, or we'll find the solutions using the NumPy functions, and there are different types of functions present. So please stay tuned with our live sessions. I'll try to be continuous. So yeah, stay updated with our channel, and that's it. Okay, so the next method is now this method is used to create an array of floating point values, okay, of a specified row and columns. Okay, of a specified row and column, but this is a sub module. It is not directly present in the NumPy, it is directly present in a sub module called as random. Okay, so the method is present in the sub module present at random dot rand. Okay, so I, j is the next, so np dot random dot rand, and in this you have to mention how many rows and how many columns you want, and let's just print j. So with 2 rows and 3 columns, you have created an array. But remember, when you use this rand, so this is going to give you floating point values between 0 and 1. Okay, so if you want to create a random array of the specified rows and columns of a specified shape, but of an integer type, okay, but of an integer type, so for that there is uh, one more method which is called as, I guess, rand end. Okay, if I remember, yeah. So let me just tell you about that also. Random dot rand int. Okay, spelling mistake. RAND. Just you have to add int in the previous one. In the rand, you have to just add int. Okay, that's it. And now let's just create it. So np.random.rand int. Now in this it takes parameters in this way. First it takes the starting part, okay, starting value. Then it takes the ending value, okay, and then it takes the size. So you have to mention the size like this. Size equals to in the tuple or in the round braces, you have to mention that how many rows, columns you want. Okay, so suppose if you want to create a 3D array, so 2 comma 3 comma 4. Okay, and let's just print the k and let's see how the array looks like. Okay, so you have get a 3-dimensional array, okay, with 2 rows and 3, okay, no, with 3 rows and 4 columns. Okay, so yeah, that is the thing there. And it has created a random, it has put some random integer values between 0 and 10. Okay, so I guess 10 is excluded here. Okay, 10 is excluded, so between 0 and 9 actually it will create, because as you can see 0 is there, 9 is there, but 10 is not there, so it means 10 is excluded. Okay, explain linspace again. Okay, where is linspace? This one. See, whenever you use linspace of, let me just clear this out. 0 between 1 and 5. Let's take the basic example, then it will be more clear for you. So, and let me just do what? Let me just give you the syntax also. Syntax of linspace, then it will be more clear. Let's say you are using linspace. So linspace takes the first parameter, which is a start. The second parameter is which linspace take is a stop, and then it takes the num. Okay, num means that how many parts you want to divide it. Let's say in 5 parts. Okay, so this is num. And that's it. So start is, now what is start here? Start is the starting value of the sequence, stop is the end value of the sequence, and num is the number of evenly spaced values. Okay, evenly spaced values means that in how many equal parts you want to divide these 2 points, 0 and 1. So now let's come to this. I want to start it from 0 and the stop is 1, stop is at 1, and I want to divide these 2 points 0 and 1 between 5 evenly spaced values. Okay, so each value will be divided in equal parts in 5 ways, in 5 parts. Okay, so that is there. So 0, 0 0.25, 0 0.5, 0 0.75, and the last part is 1. So starting and the last part is also countable. So starting part will be 0 and the end part will be the stop, what you have mentioned, and in between how many parts you want, that will be divided in equal, evenly spaced values. Okay. Now, uh, another name, have you got this? Okay. So this is the use of the linspace. Okay, and this is how it works. And yeah, that's it. Okay, now guys, one more thing I want to tell you, that I've showed you using these zeros and ones. I've showed you to create 2D arrays, how you will create a 3D array. Okay, so for 3D array, what you need to do, it's very simple. Okay, it's very much simple, nothing that much complex. In 3D, what you'll do, you have to add like this. Okay, whenever you are using 0 and 1. Now I have added one more extra 2. It means what? Okay, it's not 2, it will make it 1 also, then also it will be a 3D only. But to show you guys, I have added 2 so that you will, 2 means the extra 2. Okay, let me explain you this whole 3 things. See, this means this determines the shape. Okay, initially the shape was we were only giving rows and columns. So I have told you that rows and columns are only present in 2D matrix. If we'll talk about the 3D matrix, so in 3D matrix three things are considered. One is the depth, then there is rows, and then there is columns. So when you want to create the 3D matrix using zeros or ones or this type of functions, so then you have to mention 2, 2, 3, or any value you can take. It depends on you. Okay, so this first two means the depth, that how many blocks you want. So as you can see, when I mentioned 2, so I got 2 blocks. Okay, these are the blocks. This first part is the starting of the array, and this is mentioning that there are 2 blocks. Okay, now inside that 2 blocks, in each block how many row will be there and how many column will be there. So in each block there will be 2 rows and 3 columns. So as you can see, in each block there is 2 row and 3 column in each row. Okay, so I hope that is clear. Again, you can do it the same thing with the ones. Let's say 2, let's change the column and row now. Okay, so as you can see, this will be the answer. Now a range is not going to change. A range is going to generate a one dimensional array only. Okay, so yeah, then there is randed, and linspace is also going to give you a one dimensional array only. I is I. Then for rand you can do it. In rand you can mention uh, okay, in rand you can again do the same thing, just have you have just like you have do it with zeros and ones. And then there is rand int. Okay, in rand int also you can do it, you can mention it in the size. Okay, so I hope that's clear. If that's clear, so we'll move ahead. Okay, and we'll see the slicing. Okay, now we'll see the slicing. So slicing and indexing, these two concepts we'll see. Let's say indexing. So in indexing, what should we do? Let me just consider a 1D array first. Where is a one dimensional array? Okay, this is a one dimensional array. I'll just copy it. So I have a one dimensional array with me, and in this I have to perform first of all indexing. So B square braces, you have to use the square braces whenever you have to use indexing or slicing. So first of all, in this 1D array I want to fetch the single element, only one element. So let's say I want to fetch 3. Okay, so for that I'll write 2, so I'll get 3. So always remember the indexing always starts from 0 in Python. Okay, and in NumPy array also it starts from 0 only. So 1 is present at 0 position, 2 is present at 1 position, and so on it will be continue. Remember the first value is always present at the 0 position. Okay, so if I want to print 3, means if I want to access 3, so what I have to do, I have to just write 2, because it starts from 0. So 1 is at 0, 2 is at 1, and 3 is at 2. So I have written 2, I have get 3. Okay, so this is indexing in a 1D array. If you want to access a 2D array, so let's take an example of a 2D array also. So I'll just bring this array. Now this C is a 2D array, and now if I have to access let's say 5, okay, the element 5, then what I need to do? So you guys have to think in this way. Now in 2D arrays we talk about row and columns. Okay, and one more thing is there, parent and child. Okay, so one parent and two child list or two child array are there. So what we need to do, we need to see in this way. The first row is present at 0 position, and the second row is present at the first position. Okay, so rows also have indexing. Okay, rows also have indexing. Okay, let me just make it look more good. Wait, let me just do what? Let me just first print the array C. Okay, yeah, now it is more good, and I'll just copy it and I'll create this. I'll make it a raw. Yeah. Now, guys, the first row is present at 0 position and the second row is present at 1 position, and same order will be followed for all other rows in a 2D array. If there is one more row, if there was one more row present, so that will be present at 2 position, then 3 position, then 4th position, so on it will be continued. So now you guys only tell me that if I have to access 5, if I want to access 5, so 5 is present at which row? In 0 row it is present or in 1 row it is present? Tell me that. Okay, row 1. Yeah, row 1. Yes, correct. So that's the thing. Okay, that's the thing here, that 5 is present in row 1. Okay, that's very good. So now you guys will tell me everything. I'm not going to do. So 1, I've written 1. Okay, so when I just wrote 1 here, means when I typed 1, then what happened? Then now we are specifically focusing on this row. So now this row is excluded. Now we'll not talk about this row. Okay, so now we are talking about this row. Okay, now think like that. When we have written 1, so we are came inside this row. Now think of like that, that now we are inside this row. So in this row, again, the first element, how many elements are there inside this row? 3 elements. So the first element is present at again 0. Okay, so now I'll again give you this. So this is present at 0, this is present at 1, and this is present at 2. Okay, this is the positioning of how the values are positioned. So now tell me, 1 I have written, so I am inside this row. Now inside this row I have to access 5. So then what should I write? Yes, 1 1. People have understood. Yes, very good. So 5 is present at, as you can see here, 5 is present at 1. So I have to write 1. And just you have to print it and you will get 5. Okay, so if I have to access 6, then what I'll do, 1 comma 2, so I'll get 6. Okay, so now if I have to access 3, then what I need to do, then simple thing, first I'll make the changes here, because if I have to access 3, so 3 is present in the row 0, so I'll write 0 here, and then 3 is present at the second position. Okay, 0 1 2, so we'll get 3 also. And in this way you can access, if the array is, if the array is a 2D array, and if the array is very big also, so you have to just go in part by part. If you'll go in part by part, so it will be easy accessing. Okay, accessing will be easy for you then. Okay, now let's talk about slicing in a 2D array. So what was the array name? C, and I want to access column. Okay, so I want to access from all the rows. I want to access the first column, only the first column. So I want to access column. I'm doing column slicing here. So as you can see, okay, so I'm getting, because I've written 1, so I'll get this 2 and I'll get this 5. Okay, let me just do what, let me just print it over here, so it will be more easy for you guys. Yeah, okay, so now what I have done here, I wanted all the items. Okay, I wanted all the rows to be considered, because I wanted to perform slicing. Okay, so slicing is what, range of indexed values. Okay, initially we were accessing single element. What if you want to access multiple elements? So then slicing is the concept which we are going to use. So in slicing, I wanted to access this 2 and this 5. So it means what? That 2 and 5 are in the same column and the column is 1. Am I right? Yes, the column is 1. As you can see here, the column is 1. But one more thing to consider is that I want then these two rows both. So for that, I'll just use, if you know list slicing, so it is just similar to that. Okay. If you just know list slicing, so it is similar to that list slicing. Okay. So yeah, so if you want to consider both rows, so just leave this column blank, so it will consider the whole array, because the starting is blank and the ending is also blank, so it will consider all array together. And then if you want one column, so just mention one, so if it will give you 2 5. If you want 1 and 4, so you'll mention 0, so you'll get 1 and 4. If you want 3 and 6, so if you'll write 2 here, so you'll get 3 and 6. Okay, this is the thing. Now if you want to perform slicing row wise, so then what you will do, in which row you want to perform. So okay, let me just leave this like this, and I'll create one more. Let's say if I want to access 4 5 6, only 4 5 6, so then I know that 4 5 6 is present, is a row, and it is present in a separate row, and that is row 1. So I'll just directly write row 1, and now I'll perform the slicing here in this part. Okay, so 4 is present at 0 location, and if I want to access 4 5 6 both, so I'll leave the column like this, so it will give me 4 5 6. If I want to only access 5 and 6, then I'll do what? I'll mention the starting part, so starting part will be 1 and ending I'll leave like this, so 5 and 6. If I want to access inside the row, if I want to access only 4 5, okay, so I leave the starting part as it is, and in the ending part I'll mention 0 1, so 2. I'll ending part I'll mention 2, so I'll get only 4 5, because 2 is exclusive in nature. Okay, so this is all about slicing. I hope you've got this. Now let's just talk about indexing and slicing in a 3D array. Okay, quickly, let's just quickly see in 3D array. So yeah, d equals to np.array, and it is a 3D array, and I'll just print this array for more convenience purpose. Okay, like this. And first of all, let's try to access a single element. Okay, again the square braces, and which element you guys want to access? Let's access this 5. Okay, let's access this 5. So first of all, think like that. There is a grandparent. Inside that grandparent there is a parent. Okay, inside that parent there is what? There are two parents actually. Okay, not one parent. So there is a grandparent, then there's that grandparent has had two childs. Okay, and that two childs have two subchilds. It means the child is a parent now. So yeah, so first of all we'll mention 5 is present in which part. So this is present at 0 position, this parent, and this parent is present at 1 position. Okay, so 5 is present in 1, so we'll write 1. Okay, 1. Then after 1, now we are inside this parent. Now we are inside this parent. Inside this parent there are two childs. Okay, now in these two childs we'll consider the 5 is in which child. So again, this array, okay, this child which has 5 6 in it, it is present at 0, and this 7 8 is present at 1. Okay, so 5 6 is at 0 and 7 8 is at 1. We want to access 5, so 0, so let's write 0. Okay, now when we have written 0, so now we are inside this list. Okay, means this array or this child array. Now inside this child array, again 5 is at 0 position, 6 is at 1 position, so we have to access what? We have to access 5, so again we'll write 0. Let's see what we are getting. So we are getting 5. Okay, so that is the way. This is how it works. This is how it works. So this is how you will access a single element. Okay, if you want to access multiple elements, let's say if you want slicing to be done, so then again same concept. just like how you're doing in 2D array, you will do it in 3D array. Okay, but 3 level abstraction you will do. How? Let's say if you want to, I'll take the same example to make you guys understand it very easy way. Now I want to access 5 and 6 both. Initially I was accessing 5 only. Now I want to access 5 and 6 both. So what I need to do, again the same process. I'll go in the first parent, because this is present in this one, this row. So this row is the second row, means the second row, it means first position. Then in first position there are two childs, so 5 6 is present in the first child, so again 0. And now slicing, I'll just do like this, colon. It means take the from the very beginning till the end. Okay, and we'll get 5 6. So much easy. Okay, you have to just understand the concept, how is it working. And in 3D array also, it is just like the nested list. Okay, just like how you create a 3-dimensional list, in that also how slicing is performed, same way in arrays it is performed. Okay, same thing, everything is same. So yeah, now let me give you one more example. What if I want to access this 3 and 4. Okay, 3 and 4. So guys, do you guys want that you should access this 3 4? So if you want, so you can give me the in the comment, you can write what should I write to access 3 4. Try it, guys, try it. If you'll try it, then only you will master it. Okay, so our live session is mastering NumPy. So if you want to master NumPy, then you have to uh, uh, be with me, you have to respond, then only you will run. If you'll see that I am telling you and you guys are only listening and trying to learn, then there are many YouTube channels present in which you can go and learn. But if you want to actually learn, so if I'm saying some things that give me the output or give me the inputs which I want, so yeah, okay, I can see in the chat Alexandro is giving us. Okay, so I can see that two people have given us this. So Alejandro have given this thing. Okay, and uh, then one more person have given me the output. Okay, now he has corrected it once. Okay, so 1 comma 1 comma 1. Okay, by default I think he have included colon, so colon will be not there in array, there will be comma. So yeah, okay. And guys, let me tell you that we want to access 3 4. So I feel that both of you guys are wrong. So one is 2 4 and one is 8. Okay, so yeah, but I'm very glad that you guys at least tried it. Okay, so that's very nice. You were one step ahead of other people. Okay, so you guys at least tried it and you guys are interacting it. That's very nice, that's very good. But the correct one is, let me now tell you, and you guys will correct yourself. Now I'm not going to correct, you guys will only correct yourself. How? Let's talk about this. Guys, first of all, we want to access 3 4. Okay, so think in this way. There in the grandparent there are two parents, so 3 4 is present in which parent? First one or second one? Okay, in the first one. So first one is present at 0 and second one is present at 1. So 3 4 is present in the first parent. So first parent will be what? Okay, 0 or 1. What should I write first? I want to access 3 4 and 3 4 is present in the first parent, which is at the position 0. So I'll write 0 here. Okay, then now we are inside this. Now we are inside this. Okay, now inside this, tell me that again there are two childs. In the parent there are two childs. there is one child which has 1 2, there is second child which has 3 4. So the child which has 1 2 is present at the position what, 0, and the second one, the child which has 3 4, which is present at 1 position. So now what should I write here, 0 or 1? Yes, Alejandro is correct. The first parent which is at 0 position, so first I'll write 0. Now tell me, what should I write, 0 or 1? Okay, first child, that's very good, that is position number 1. Okay, okay, first child position 1, it means you mean to say the second child, and yes, yes, correct, correct. I'm not going to, I will not confuse you. You have said 1, 1 is correct. Okay, okay. Now guys, you tell me, I want to access both 3 and 4. So what I'll do, okay, I'll just leave it a simple colon. Okay, I'll just leave a simple colon, and simple colon means that the starting part I'm not given. It means it will take the whole starting and the whole ending. Means it will start from the very beginning and will go till the end. And that's it. Okay, and that's it. That's the correct answer. We have successfully accessed 3 and 4. Okay, understood? Yes, for all elements, just put the colon. Yeah, and here you go. We have successfully done accessing in 3D array and slicing in 3D array, and that's it. You don't need to go ahead. 4D array and 5D arrays are not that much used in some of the ways or in some of the problems you will face, but for basics thing you're not going to face until 3D array. It is outmost. Okay, so initially I have bring up with many contents. Many contents. I felt that I will cover it in 1 hour or 1.5 hour session, but I feel that no, that is not possible. So we'll do whatever the next things which are left, that we'll see in the next live session. And yes, I know you guys want me to just be regular, and believe me, I just try to be regular, but there are some other works also. I just do YouTube just for you guys, to make you guys learn, and for me also, I also get to revise the things. Okay, so yeah, that is the thing. So the next things which are left is, in the starting of the live session I have said you that there are some of the NumPy statistics operations. For that there are numerous methods and functions present in NumPy, just like mean, max, sum, mean, median, standard deviation, variation, and there are many more. So, and then in the array also few topics are left, just like the element wise operation and matrix operations. So now what I want, let's cover those things in the next live session. I'll try to uh, uh, be more regular. Okay, so yeah, so that's all for this live session, guys. I hope you guys learn something. Okay, and go and explore NumPy array, okay, with your own also, and with this also, with this file. Okay, if you have noted it out, or you have the video with you. Okay, and it will always remain in the channel. You can go and anytime you can practice it. Okay, yes, another name, you I think need more practice. Obviously bro, practice is important. Okay, practice is important. If you'll practice it, then only you can be perfect. If you'll see that one time you will see my live and you think that you will learn it, so no, it's not that thing. You have to go and watch the live again and again, and then you have to practice with your own. uh Alejandro is saying, I appreciate your effort on India's Sunday night. Thank you. Thank you, bro. Thank you. But it's not like that. Whenever I get free, I just take the live. Okay. Initially, the timing was 5:30 p.m. my evening. Okay, that is my permanent time, and I feel comfortable in that time. But today I was not free at that time, so I just wanted to take the live. So that's why I scheduled the live at 9 p.m. Okay. So yeah, that's that's the wrap. Okay, guys. We covered not everything, but yeah, till indexing and slicing, I feel that those who have attended the live session till indexing and slicing, I feel that you guys will practice it and you guys will be perfect. And then from the next live session we'll continue after indexing and slicing, because if I'll continue with again from the very basics, then will not be, then there will be very, it will take much time, and this is a very big topic. Whole data science thing, it is a very big topic. Okay, it is not a small topic, it is a very big topic. So if you guys have to uh, finish it really quickly, so in the next live session we'll start with the next thing, so please revise till this. Okay, so that's it. Okay guys, thank you for joining the live session. It means a lot when you guys interact with me, and I hope you guys are learning Python, learning NumPy, data science. Okay, and that's all. Thank you for watching. Let's end the live. Okay.